A solid-state battery factory just broke ground in Japan. That matters because Toyota has been promising this since 2017. Every year, it's been 3 years away. But this time, there's actual concrete in Kita, Kyushu. Is the battery industry finally telling the truth? Or is this hype cycle number 6? In this episode, 3 questions. First, why hasn't a single solid-state battery shipped in a consumer car after a decade of billions? Second, sulfide, oxide, polymer, 3 chemistries racing, only 1 scales. Which one? Third, are the 2026 milestones real, or just more promises? Today's lithium-ion is hitting a physical wall around 300 watt-hours per kilogram. Solid-state targets 500, which doubles EV range. Charge to 80% in under 10 minutes. And the flammable liquid electrolyte? Replaced by a solid thermal runaway essentially disappears. This isn't an upgrade. It's a different engine. Which is why everybody wants one. And why nobody has shipped one yet. The lab works. The factory doesn't. 3 walls. Wall 1, sulfide electrolytes react with moisture to produce hydrogen sulfide, the same toxic gas used in chemical warfare. Manufacturing needs air below 1 part per million humidity. That infrastructure costs 10 to 15 times a standard battery line. Wall 2, solid-solid interface. Liquid electrolytes wet every surface automatically. Rigid solids must maintain atomic contact through thousands of cycles. Dendrites and pressure eat away at that contact over time. Wall 3, yield. Early pilot lines reported yields under 5%. You need volume to cut cost, but you need a product to get volume. Classic chicken and egg. 3 chemistries, 3 bets. Sulfide Toyota, solid power, CATL, has the best physics. Highest ionic conductivity, cold traceable. The catch, moisture kills it, and the raw material barely exists at industrial scale. Oxide, QuantumScape's bet, is chemically stable. But it's ceramic. Brittle. Requires sintering above 1000 degrees Celsius. Polymer, LG's early work, is the easiest to manufacture. But conductivity requires 60 to 80 degree operating temperatures, and energy density ceilings are lower. My read, sulfide is winning the physics war, but losing the manufacturing war. Whoever solves moisture at scale takes the entire market. 4 tiers. Automakers, Toyota, going it alone with Idemitsu and Sumitomo. Pure tech companies, QuantumScape and Solid Power, both burning cash. QuantumScape lost $435 million in 2025 against $19.5 million in revenue. 22 to 1. Cell manufacturers, Samsung SDI, LG, CATL, all profitable, all building parallel SSB programs. Samsung SDI just joined Solid Power's alliance. And materials players Idemitsu, which you've probably never heard of. In my view, the hidden winner of this story. QuantumScape, $435 million in losses. 19.5 million earned. 22 to 1. By any normal standard, a disaster. But February 2026 changed the question. The Eagle line went live in San Jose, an automated pilot production system integrating the new Cobra separator process. For the first time, they can produce cells at repeatable scale, not just in a lab. The question is no longer, can we make a great cell? It's, can we make 1,000 identical cells per day and license that recipe? In my view, QS has roughly 3 years of runway. Eagle line is real. But licensing a process nobody has proven at volume, that's still a hypothesis. Toyota has been working on this since 1988. The promises, mass production by 2022 missed. Tokyo Olympic Showcase never materialized. Then 2027 to 2028 for first vehicles. But January 2026 is different. Idemitsu broke ground on a lithium sulfide plant in Kita, Kyushu. Not a press release. An actual construction site. Target, mass production of sulfide electrolyte by 2027, feeding limited Lexus models with 1200 km range and 10-minute charging. Toyota holds over 1,000 solid-state patents, more than any other automaker. They've been quiet because they've been working. The difference this time, there's concrete in the ground. 3 events, 90 days, 3 different industry layers. Technology layer, QuantumScape's Eagle line activated in February. Automated ceramic separator production at repeatable quality. Materials layer. Idemitsu broke ground on its lithium sulfide plant in January, the first industrial facility for the raw material everything sulfide-based depends on. Manufacturing layer. Samsung SDI joined the Solid Power and BMW alliance in October. One of the world's 3 largest cell makers committed engineering resources. Cell giants don't do that for optics. Past hype cycles came from one layer, usually startups issuing press releases. This time, tech, materials, and manufacturing are moving simultaneously. That is what industry synchronization actually looks like. The economics are still brutal. Solid state today, $800 to $1,200 per kilowatt hour. Lithium ion, below 100. A 10x gap that engineering alone cannot close. And there's a supply bottleneck nobody talks about. Lithium sulfide, the essential material for sulfide electrolytes, has global production under 100 tons per year. One Lexus pack needs roughly half a ton. Toyota shipping 20,000 vehicles consumes the entire world's annual supply. Twice. Idemitsu controls over 80% of the technology-grade patents. Current lithium sulfide price, $15,000 per kilogram. It must fall below $3,000 for mass-market SSB economics to work. Forget the cell makers. Watch the materials. Who wins, who loses? Winners. Idemitsu owns the lithium sulfide bottleneck. Samsung SDI scale plus first mover commitment. CATL will dominate Chinese EV solid state. High risk, QuantumScape and Solid Power, limited runway, and proven licensing models. Wait and see. Ford, GM, Volkswagen, no captive SSB tech or materials. Price takers in the next cycle. LG Energy Solution, strong scale, SSB roadmap slipped to 2030. Under pressure, today's lithium-ion capacity builders. If solid state hits volume in 2028 or 2029, $10 billion of recently built capacity faces early obsolescence. The companies that won the last battle might lose the next one because they built the wrong factories. My base case, 55% probability. Toyota launches a limited Lexus in 2027. Low thousands of units. Technology validated publicly, economics unchanged. Real mass market window, 2029 to 2030. Watch 3 signals. First, Toyota's 2027 Lexus delivery count. Under 10,000 yield still broken. Over 50,000, the manufacturing wall has cracked. Second, lithium sulfide spot price. Below $3,000 per kilogram signals viable economics. Third, QuantumScape's 2026 customer billings. Below 30 million, licensing thesis in trouble. Positive catalyst, a major Western automaker names a solid-state production partner this year. Negative, any thermal incident in an early SSB test vehicle sets back public trust by years. I'm Big Z, follow me, see you in the next deep dive.